Hello and welcome dear students to this online channel. I am Shravan Kumar, your maths lecturer. In the last lecture we have seen types of matrices, that is singular and non-singular matrix. Now the next type of matrix is symmetric matrix. Before we see the symmetric matrix, you should know what is transpose of a matrix. Transpose of a matrix. Transpose of a matrix A is denoted by A dash or AT. And what is transpose? Transpose of a matrix is obtained by interchanging rows and columns. For example, A is a matrix having elements 1, minus 1, 2, 3, 4, minus 5. It contains 2 rows and 3 columns. If we interchange all rows and columns, so A transpose is given by the first row is 1, minus 1, 2. When it becomes first column, second row is 3, 4, minus 5. When it becomes second column, then this matrix obtained is known as what? Transpose of a matrix. Now how to find the transpose of a matrix? By interchanging rows and column of a matrix, the matrix obtained is known as what? Transpose of a matrix. It is denoted by AT, A transpose or A dash. Next, let us take another example. B matrix contains the elements 3, minus 5, 2, 4. Now how to find the transpose of this matrix? Here the first row is 3, minus 5. So write down first row as first column. Second row is 2, 4. So write down second row as second column. So this matrix obtained is known as what? Transpose of a matrix. Now what is the use of transpose of a matrix in symmetric matrix? So symmetric matrix is a type of square matrix in which A equal to A transpose. A matrix in which A equal to A transpose is known as what? Symmetric matrix. For example, if you take an example of a matrix of order 3 by 3, let us take an example of a matrix of order 3 by 3, 1, 2, 3, 2, 5, 4, 3, 4, 7. Now find the transpose of this matrix. If we find the transpose of this matrix, means interchange rows and columns. 1, 2, 3 is the first row, so it becomes first column. 2, 5, 4 is second row, so it becomes 2, 5, 4 is second column. 3, 4, 7 is the third row, so it becomes third column. Now observe matrix A and B. 1, 2, 3, 1, 2, 3, 2, 5, 4, 2, 5, 4, 3, 4, 7, 3, 4, 7. So A is equal to A transpose. Here A equal to A transpose. Therefore matrix A is known as what? Symmetric matrix. So matrix A is known as symmetric matrix. What is symmetric matrix? Symmetric matrix is a square matrix in which A equal to A transpose. Easily you can identify with a short trick. In a square symmetric matrix is a matrix in which Aij equal to Aji. Aij equal to Aji. Now what is the meaning of Aij equal to Aji? A12 element is equal to A21. A13 element is equal to A31. A23 element is equal to A32. Now let us see here. This position is what? A12 and this is A21. These two elements are same. In case of symmetric matrices, this is the position of A13. This is A13 and the A13 is equal to A31. A13 is equal to A31. This is A23 and this is A32. So these two elements are same and these two elements are same, and symmetric matrix is independent on diagonal elements. Diagonal elements you can put 1, 5, 7, 3, 2, 5, any numbers you can put. But symmetric matrix, in symmetric matrix Aij is always equal to Aji. That means A equal to A transpose. So symmetric matrix is a type of square matrix in which A equal to A transpose or Aij equal to Aji. Now next type of matrix is Skewsymmetric matrix. Next type of matrix is Skewsymmetric matrix. Skewsymmetric matrix. Skewsymmetric matrix is a matrix. Skewsymmetric matrix. Skewsymmetric matrix is a matrix in which A equal to minus of A transpose. A equal to minus of A transpose or A transpose equal to minus of A. If you take minus sign in the left hand side, then it becomes A transpose equal to minus of A. So skew symmetric matrix, let us take an example of skew symmetric matrix. 0, 2, minus 3, minus 2, 0, 5, 3, minus 5, 0. Now find the transpose of this matrix A. Now what is the transpose interchanging rows and column? 0, 2, minus 3, 0, 2, minus 3. First row you have to write as first column. Minus 2, 0, 5, 3, minus 5, 0. Now observe matrix A and A transpose, these two matrices are not equal because here 0, 2, minus 3 and here 0, minus 2, 3. But if you take minus sign common from A transpose, now take minus sign common, it becomes 0, 2, minus 3, 0, 2, minus 3 and here minus 2, 0, 5, minus 2, 0, 5. Next is 3, minus 5, 0, 3, minus 5, 0. Now this matrix 0, 2, minus 3, minus 2, 0, 5, 3, minus 5, 0 is equivalent to what? A. So this matrix we can write as A. Therefore in this case A transpose equal to minus of A. Therefore this matrix A is an example of skew symmetric matrix. Now so in short, how you can identify whether the given matrix is a symmetric or skew symmetric matrix. In skew symmetric matrix, the element Aij equal to minus of Aj. That means the elements A12 is equal to minus of A21. The element A32 is equal to minus of A23. Let us see. This is the element of A12, one first row and second column. So 2, minus 2. If it is minus, then it is plus. If it is plus, then it is minus. And diagonal elements are always 0. Diagonal elements are always 0 in case of skew symmetric matrix. So skew symmetric is a matrix in which A equal to minus of A transpose or A transpose equal to minus of A. In short, Aij equal to minus of Aj. And in skew symmetric matrices, diagonal elements are always 0. But for symmetric matrices, it is not so. So with this we have completed two types of matrices, that is symmetric and skew symmetric matrix. Let us take the next type of matrix, divide lower triangular and upper triangular matrices. These are the last types of matrices, upper triangular and lower triangular matrices. Upper triangular matrix and lower triangular matrix. Upper triangular matrix is a matrix in which the elements below diagonal are 0. These are known as diagonal elements. Suppose 1, 2, 3, 4, 5, 6, 0, 0, 0. So this is an example of upper triangular matrix. Now what is the definition of upper triangular matrix? A square matrix in which the elements below diagonal are always 0. Means below diagonal means all these three elements are always 0. Means a triangle is formed above these three elements. Therefore this matrix is known as upper triangular matrix. So what is upper triangular matrix? Upper triangular matrix is a matrix in which the elements below diagonal are always 0. Let us take another example of order 2, 2, 3, 0, 5. Here the diagonal elements are 2, 5 and the elements below diagonal are 0, is 0 and a triangle is formed above this 0. Therefore this type of matrix is what? Upper triangular matrix. Now the last type of matrix is lower triangular matrix. Now opposite of upper triangular, in upper triangular the elements below diagonal are 0 and in lower triangular the elements above diagonal are 0. Means a triangle is formed below all three 0. Let us take the example. A is a matrix having elements 1, 0, 0, 2, 3, 0, 5, minus 6, 7. Now what are the diagonal elements? Here 1, 3, 7 are known as diagonal elements and the elements above diagonal. In lower triangular, the elements above diagonal are always 0 and a triangle is formed below these three elements. Therefore this matrix is known as what? A lower triangular matrix. Suppose B is a matrix having elements 1, 0, 0, 2. So what are the diagonal elements here? Diagonal elements are 1, 2, and the elements above diagonal and below diagonal both are 0. Therefore, this is an example of upper as well as lower triangular matrices. So diagonal matrix is always upper as well as lower. Scalar matrix is also upper as well as lower. Identity matrix is also upper as well as lower triangular matrix. Together, lower and upper triangular matrices are known as triangular matrices. So with this we have completed the types of matrices. From the next lecture we will see algebra of matrices. Thank you.